Hi, I'm Karyn Hodgens, creator of Nifty Numbers and Math Medley Family Math Nights. And in this video, I'm going to share with you some strategies for working with your upper elementary students in fractions, specifically dividing and multiplying fractions, coming up with equivalent fractions, and then simplifying fractions. Okay, so I'm going to start with multiplying fractions, and we're going to get kids to look at patterns in multiplying fractions and then come up with a rule to describe those patterns. And I'm going to start with the fraction 2/3 times 1/2. Let's say that we have a recipe that calls for 2/3 cup of brown sugar, and we want to cut the recipe in half. So what is half of 2/3? Now, I remind students that when they're in second, third, and fourth grade and they're studying their multiplication facts, that they may have done that, hopefully they did, using rectangular arrays. Okay, so this would be representing 4 times 2, the total of 8. Okay, so we're going to use that same idea when we teach kids about multiplying fractions, that array model. Okay, so the first thing we need to do is to create a rectangular array that is 3 by 2. So I'm going to create, so that's 3 rows by 2 columns. So here is my array. Okay, and then the next thing I need to do is shade 2/3 of that array. Now here are my thirds. There's 1/3, 2/3, and 3/3. So I need to shade 2/3 of that. So I'm going to do that, and then I'm going to shade it like this. Okay. Now the next thing I need to do is to shade half of it. And so my halves, I'm going to use a different color to do this. My halves are represented here. Here's 1/2, and here's 2 halves. So 1/2 would be represented all the way down like that, and then I'm going to shade this part like that. Okay, so now my answer is, the denominator is the total rectangle, and I have 1, 2, 3, 4, 5, 6 squares in that rectangle. Oops. And the numerator is the shaded region, or the intersection of both shaded regions, and that is 1, 2. So my answer to 2/3 times half is 2/6. Okay, let's try another one. Let's do 5/7 times the 3/5. Okay, 5/7 times 3/5. So we need to make a rectangle that is 7 by 5. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Okay, here's my rectangle. Okay, now I need to shade 5/7 of that, and my sevenths are here. 1, 2, 3, 4, 5, 6, 7. And I need 5 of those, so that would give me this much here. And then I would shade it like that. Okay, so my next thing is that I need to shade 3/5, and again, I'm going to switch colors here. 3/5, and my fifths go in this direction. There's 1, 2, 3, 4, 5. 5 equal pieces, right? I need to shade 3 of those 5 equal pieces. So, and that's why I need to go all the way down like that. And now I'm going to shade it like this. And my answer is, the total rectangle has 35 squares, and the intersection of the shaded regions has 3, 6, 9, 12, 15. So my answer to 5/7 times 3/5 is 15/35. Now at this point, I let students, they have graph paper, and I let students create a whole bunch of different problems, multiplying the fractions problems on their graph paper, as many as the graph paper can handle. And then we collect data, and then we look for patterns in that data. And pretty soon kids are going to come up with the rule that if you multiply the numerators across and you multiply the denominators across, you will get your answer. And that is the rule for multiplying fractions. Now what's really important here is that the students have visualized in their head what that looks like. Back to this one up here, the 2/3 is clearly represented right here by the green shaded areas. They can see that in their head, and they're taking half of that 2/3. They can clearly see that as well. So it's a very visual representation of what this problem is asking them to do. Okay, so it's really important for them to have that foundation, and then of course they discover the rule, and then the next time they see, you know, two fractions they need to multiply, they know exactly what to do. Okay, so the next thing I'm going to talk about is simplifying fractions. Now let's talk about equivalent fractions first, and then we'll get to simplifying. Okay, so equivalent fractions, and I am going to assume that the students have had some experiences dealing with finding equivalent fractions already using things like pattern blocks. So for example, here's one hexagon, right? And so if we put these trapezoids on that hexagon, then, okay, this hexagon here represents half, or one of the two pieces needed to cover that hole or that hexagon. Or these trapezoids represent 2 out of 2, so 2 halves needed to cover that hole. They will discover that there are 6 triangles that make up this hexagon. So 6 equals 1 hole. And if this is a 6th, then they will discover that 3 of them, okay, makes up this, this trapezoid. So 3/6 is the same as 1/2. Okay, so they've had some experience with that. You may have done some paper folding activities with them as well to talk about equivalent fractions. So you take a strip of paper, right, and you fold it in half, and then you open it up again, and students write 1/2, and then 2 halves over here. Super important that we get our 2 halves in there. And they fold it back up again, and then they fold it into fourths, right? So when they open it up, they can see those fourths there. And then they write on the folds 1/4, 2/4, and so forth. They fold it back up again, they fold it into eighths, and they record those on here. And you can see clearly indicated there these equivalent fractions. Okay, 1/2 is equal to 2/4 is equal to 4/8. So they've done these kinds of experiences maybe with circle fractions and so forth. So they have a little bit of a foundation of equivalent fractions. Okay, so now we're going to use the power of the number 1 to generate more equivalent fractions. Okay, so first I want to talk about the idea that we talked about back here, where 2 halves is equal to 1. Super important, right? 2 halves is the same as 1, okay? Just like 126 over 126 is the same as 1. In fact, I might do this. I might say, I'll take this 2 and I'll replace it with a dot, and I'll take this 2 and I'll replace that with a dot, and I'll say, look, what does that look like? It looks like the division symbol, right? Totally cool, because that's exactly what it means. It means 2 divided by 2 equals 1. Awesome. Okay. So the other thing that students need to understand is the identity property of multiplication, which states that any number in the whole wide world that is multiplied by 1 will always be that number. Okay? So for example, 5 times 1 equals 5, or 2063 times 1 equals 2063, and so forth. Okay, so that's important to understand as well. So now I'm going to ask them, okay then, what does 1/2 times 1 equal? And of course, they're going to tell me 1/2 times 1 equals 1/2, and they're going to be right because that is what it equals. Okay, so now I'm going to replace this 1 here by a fraction, but the fraction is going to be equal to 1. So let me replace it with 2 over 2. Now that's the same as 1, right? So I like to draw this little 1 around it, kind of something like that. So what I'm really doing is multiplying. Let me get rid of this guy over here, that's not there. 1/2 times 1. I am going to end up with 1/2, but now I'm looking for equivalent fractions. So I am going to simply multiply my numerators across and my denominators. And remember, we already know that that's the rule, right? Because we've looked for patterns and come up with that rule. So 1 times 2 is 2, and 2 times 2 is 4. And what we've created here is an equivalent fraction. Awesome. Okay, let's do another one. We could do 1/2 times 1 again, right? But this time, my 1 is going to be represented by 3/3. And that answer is 3/6. So 1/2 is equivalent to 3/6 as well. Okay, so now we're going to go in the opposite direction. So the opposite of multiplication is division. So we're going to use division to help us simplify the fraction 3/6. And simplifying fractions simply means bringing the fraction down so that the numerator and the denominator do not share a common prime factor. And if you remember, prime numbers are 2, 3, 5, 7, 11, and so forth, right? Well, if we look at 3/6, 3 is a prime, so we're good there. Okay. Now, if we broke 6 down to its primes, we would end up with 2 times 3, and we would have a 3 down here. So they share a common prime, and we don't want that. We want to simplify it. So we are going to take 3/6, and we are going to divide it by 1, right? We're actually going to divide it by a fraction that's equivalent to 1. Okay, and so what number goes evenly into the numerator and the denominator, and that would be 3. So we're going to divide it by 3/3 because we're going to divide it by 1, right? 3 divided by 3 is 1, and 6 divided by 3 is 2. We've come full circle. We're back at 1/2. And so that is a way to simplify fractions. Now I prefer using the word simplify over reduce. Reduce implies that something is getting smaller, and nothing is getting smaller here. So I really encourage the use of the word simplify over reduce. Okay, so now we're going to talk about dividing fractions, and the key to teaching kids about dividing fractions, because they can be super confusing, is getting kids to visualize what the problem is asking them. So for example, if I had 2 divided by half, let's say I had 2 apples, and I want to divide them into half, how many halves will I have, or how many pieces will I have? And of course, we know that to be 4, but let's show this visually. Okay, so we have 1, 2, okay, I'm not going to draw apples, I'm going to draw bars instead. So there's 2, right? And we want to, and the question that the students ask is very important. And the question here is, how many halves are in 2? So here's my 2, right? And this is going to represent my half. If you took my whole and you divided it, okay, so this would be half of that whole. So the question again is, how many of these are in here? And you can actually have students create these bars out of paper and then cut them out and lay them on top, and they will discover that yes, indeed, 4 halves are in 2. So getting them to really visualize and understand what that problem is asking them. Okay, so let's do another one. Let's do 1/2 divided by 1/4. Okay, so what's the question here? The question is, how many fourths are in 1/2? So I'm going to draw pictures again. Okay, now here's my whole. We start with the whole, right? And there's my half. So here's this half over here. And I'm asking how many fourths, these little guys right there, how many of these are in that half? We need to get kids to visualize what this is asking them. And then again, they can make the paper and put it on top, and they would see that the answer to that is 2. There are 2/4 that go inside that half. Now it gets a little more complicated when we do things like 2/3 divided by 1/4. Okay. The question is, how many fourths are there in 2/3? And again, if I'm going to draw this, okay, this is 2/3 right here. I want to find out how many of these guys fit in there. And when they do this with paper, it doesn't fit evenly into that. But the important part at this point is that the students can visualize what this question is asking, and they know to ask how many fourths are in 2/3. You want them to be really comfortable with that. Okay, so now I'm going to solve this. We're going to actually solve this a couple of ways. Okay, and I'm going to do it using a word problem. So let's say I had 2/3 cans of paint. Okay, so here's my can of paint, and it's 2/3 full right there. Okay, and I know that it takes 1/4 of a can of paint to paint one of my walls. I know that. But I only have 2/3 of a can left. So I want to know how many walls can I paint with this can of paint. So it's 2/3 is what I have. And I'm dividing that by 1/4 equals, okay, and my question is how many walls will I be able to cover? Okay, so one of the ways that we could do this is simply to find a common denominator. Now we've done equivalent fractions, so students should be familiar. We're trying to find an equivalent fraction for 2/3 and for each one of those, but we need to get a common denominator first. So if we multiply 3 times 4, we need to find a denominator that 3 goes into evenly and 4 goes into evenly, right? And a very simple way to do that is to multiply 3 times 4. So we know that we need to multiply 2/3, okay, by some number, by 1. We're creating an equivalent fraction, right? Where we're going to end up with a fraction that has a denominator of 12. What do we multiply 3 by to get to 12? 4, which means that this is going to be 1, right? Then the top one has to be 4 as well. So we multiply across because we know that now. So 2 times 4 is 8. So this is an equivalent fraction for that. So now we need to find an equivalent fraction for 1/4. Again, where we're going to multiply it by 1. Okay? And we're going to end up with a fraction that has a denominator of 12. What do we multiply 4 by to get to 12? Well, that's 3. So we need to make this 1. So that's 3/3. 1 times 3 is 3. And this becomes an equivalent fraction for that. Okay, so how do we use that? Well, we're now going to go 8/12 divided by 3/12 equals, super easy to divide 12 by 12 is just 1, right? 8 divided by 3 is 8/3. 8/3 divided by, because they know what that means, 1 is 8/3. Okay, and that is an improper fraction, so 8 divided by 3 is 2 and 2/3. How does that fit into my problem? I can paint 2 and 2/3 wall with the paint that I have left. Okay, that's a lot of work, but it gets us the answer, right? Now I'm going to show you another way to do it that uses the power of the number 1. So let's go back to 2/3 can of paint divided by 1/4 equals, okay. So now, wouldn't it be super easy if we could just divide by the number 1? Because any number divided by 1 is going to be that number. So how could we turn this fraction 1/4 into the number 1? And I pose that out to students. It's a great problem for them to think of. How can this, you're going to multiply this by something and you're going to end up with 1. I don't know. What do you think, you guys? What can we do there? And put it out to them and see what they come up with. And often they come up with, well, 1/4 divided by 4/1, or the reciprocal, right, equals 1, because that's really 4/4, and we know that 4/4 is 1. Well, what a great idea. Let's do that. So, first, however, let me give you a problem. 12 divided by 4 is 3, right? Okay. If I multiplied 12 by 2 and I multiplied 4 by 2, now I have 24 divided by 8 equals. Does 24 divided by 8 equal 3? Absolutely. Okay, why did I do this? Because I want you to see that if you multiply this number and that number by the same number, the answer will be the same. That's important for this the problem that we're going to solve right now. Okay, so we're going to multiply we want this to become a 1, right? So we're going to multiply 1/4 by 4/1 because we know that that's going to be 1. So if we did it to this side, we need to do it to the other side. So now we're going to multiply 2/3 by 4/1, and students know that, well, this right here is equal to 1, right? So you really end up with 4/1 times 2/3, which gives us, we multiply across, 8/3, which gives us 2 and 2/3, the same answer that we got before. Okay, using the power of dividing by 1, right? So we do enough of these examples, and pretty soon there's going to be someone who says, why do we have to go through all these steps? Why can't we just take that second fraction and invert it and multiply? And I go, well, let's see if that works. So 2/3 times 4/1 equals 8/3. Oh my gosh, it's the same thing, equals 2 2/3. Let's try it again. And you do a few more, right? And pretty soon they discover that. Isn't it easier and more efficient to simply invert the second fraction and multiply across? And sure enough, it is. It is a more efficient way to solve that problem. But we want them to understand why that works first. That's super important. It's kind of like the cute little rhyme that says, mine is not to reason why, just invert and multiply, right? But when we teach kids that dividing fractions simply means inverting that second fraction and multiplying across without teaching them, giving them an understanding for why that works, math becomes this mysterious subject filled with rules and procedures that they have to memorize, and that does not build mathematically confident students. We need to give our students opportunities to make sense of the math that they are learning. So hopefully today I have shared with you some strategies that will make fractions a little bit easier for your students.